Okay guys, so we're going to learn how to multiply binomials today. And this is really known as the FOIL method, which is a super useful tool as we get into more advanced algebra. So this is kind of like our ultimate goal here, is to get into FOIL method so we can then learn how to factor, which is the next thing that we're going to work on. So we're going to start with learning how to do it with box method. Now the reason why we're going to learn it with box method is because box method really comes from those algebra tiles that we've been working with. And so we're going to set this problem up exactly how we would algebra tiles. So step one, you notice, is to create a 2 by 2 grid. So multiplying the following, x plus 2 times x minus 1. So again, looking at our steps, I need to create a 2 by 2 grid. This is very similar to what we did when we were setting up our algebra tiles. So see, I made that T shape like we did with our algebra tiles. Now the only difference is now I'm going to put a line here to separate my terms, and a line here to separate my terms. So you'll notice I actually made mine a little bit too big, which is okay. Right? There's nothing wrong with making it too big of a box. And we'll just make it go down all the way because I like symmetry. So up here, we're gonna, well, just like we do with our algebra tiles, we're gonna do x and 2. And then up here, we're gonna do x and negative 1. Okay? So just like our algebra tiles, we have the rectangle, the ones, well, and that's kind of a square at once. So that was step 2, place the terms in the spaces above, right? And actually, let's say and side. Right, so in the first column and first row. Now we're gonna multiply the rows. So just like we did with our algebra tiles, we know x times x makes x squared, right? Remember, that's the green tile. And then x times negative 1 is going to be negative x. Over here I have 2 times x, which is 2x, and 2 times negative 1, which is going to be negative 2. So notice that I did this row times this column, and I did the second row times the second column. So now I have all of my terms. And so again, just like our algebra tiles, I'm going to start by rewriting it. That's what we have so far. So far, we have x squared plus 2x minus x minus 2. And if I combine my like terms, which is the last step, which is right here, the 2x minus x, well, 2x minus x is just x. So my answer is going to be x squared plus x minus 2. So that's how we can use the box method to multiply the binomial. So again, exactly like what we just did with algebra tiles. So here we're going to do something a little more complicated. We have 2x minus 1 and x plus 3. So I'm going to set it up the same way. I'm going to make that T shape. Make it smaller this time, since now I know how big I need to make it. I'm not just winging it. And then I'm going to break it up into the 2 columns that I need. Okay, so I have my T chart. I guess technically this would be like a, nope, and actually I need another one, don't I? I mean, I guess technically it's not a 2 by 2. The reason why I say 2 by 2 is because we're only going to use these squares right here. All right, but anyways, putting this one over here, I got 2x, and I got minus 1, and then I have x and plus 3. So again, going through our process, 2x times x is 2x squared. 2x times 3 is going to be 6x. Remember, you just multiply the coefficients. And then I have negative 1 times x, which is negative x, and negative 1 times 3, which is negative 3. So now rewriting all of my terms, I got 2x squared minus x plus 6x and minus 3. So now when I combine my like terms, I'm just combining the negative x and 6x. Negative 1 plus 6 is 5. So I'm going to get 2x squared plus 5x minus 3. And that's my solution. All right. So what's neat about this box method is we can also use it for bigger polynomials. So this is just a binomial by a binomial. But what if we had a binomial by a trinomial? When we were working with algebra tiles, we couldn't do this because the biggest that our algebra tiles went up to was x squared. But because we're using this box method, it's the same idea as the algebra tiles, but this will allow for us to go up to x squared. We could technically go up as high as we wanted to, but we're going to try to be efficient about it. So this time I do need it to go down 3, because this one, it's not going to be a 2 by 2. It's actually going to be a 2 by 3. And actually, I still made it go down too far. Silly mistake. All right, and then the reason why it's a 2 by 3 is because I still only have 2 terms with the first item. But on the other end, I have a trinomial, which has 3 terms. Expression, using our vocab. Okay, so here, and then of course, cut it in half like so. And yes, Miss A made it too long. So here we're gonna have x and plus 4. And then here I have x squared minus 3x minus 2. So this is gonna be the exact same way that we did these. We're just gonna keep going. So if I start out first, I'm gonna have x times x squared, which is gonna give me x cubed. Then I have x times negative 3x, which is negative 3x squared. And then I have x times negative 2, which is negative 2x. So that's the first row. So now we move on to the second row. Now I have 4 times x squared, which is 4x squared. I have 4 times negative 3x, which is going to be negative 12x. And then I have 4 times negative 2, which is negative 8. So you can see how using those algebra tiles came in handy, because now I have x cubed, which is its own term. I'm going to have to combine the 4x squared minus 3x squared. What I like about doing it this way too also is actually it goes ahead, if you go by columns, it lines it up for you in the right order. So it puts it in standard form for you, which is going to make your combining like terms easier. And then I have minus 12x minus 2x. It makes it easier because you don't have to look for anything. And then minus 8. So when I go by and I combine my like terms, 4x minus 3x squared is x squared. So far I have x cubed plus x squared. Negative 12x minus 2x is negative 14x, and then just the minus 8. So that is the product of my binomial and my trinomial, okay? So that's using the box method. Again, we'll go over both of them and we'll decide as a class which one we want to use going forward, but they both get you to the same result. This one just kind of organizes the information a little better for you. So standard method, when you guys get into big boy math, this is usually what people do. And so it might be nice to kind of try it this way, but I've seen kids all the way through calculus use this way, and there's nothing wrong with that. This way is how you organize your method, and you can actually, as we get into higher level maths, this is a cool way to also go backwards and do polynomial long division. So again, both methods are great. It just really depends on what your preference is. This is how I was trained, but I'm really starting to like this method just because it puts everything out there so clearly. So the standard method is called foiling, with the acronym FOIL. FOIL stands for something because it's an acronym. F is for first, which means that you're going to start with you multiplying the first terms only. So in here, in our first problem, it's very similar to the problems that we did up here, but I'm just going to do x times x. That's what it means by doing the first term. So x times x gives me x squared. Actually, when you guys were doing monomials by binomials, this is what you were doing. You were technically distributing. Foiling is like an awesome distributive property. All right, O. O is for outside. So now you do the outside terms. That means I'm going to multiply the x by the 1. So x times 1 is just x. I is for inside. That means I'm doing the negative 2 to the x. Negative 2 times x is negative 2x. And then L is for last. This means we're multiplying the last terms, which in this case is the negative 2 and the 1. They're the last terms of each expression. So negative 2 times 1 is negative 2. Once you have it like this, again, it's just combining like terms. So x minus 2x is negative x. So our answer is going to be x squared minus x minus 2. What's nice about using this method is it does not take up nearly as much space as using the box method. Notice that, well, we had different problems, but we get to the right answer. It just takes less steps, less showing your work. Okay. Part B, we can do it the same way. So we don't need to make bigger boxes. We just keep doing it the same way. So again, practicing with the first term, 2x times x. That's going to give me 2x squared. Outside is 2x times negative 3, which is negative 6x. Inside, which is 1 times x, which is 1x, or just x. And then finally last, 1 times negative 3, which is negative 3. Again, combine your like terms. That's going to be the negative 6x plus x. So my answer is going to be 2x squared minus 5x minus 3. Okay. All right, last one. This is, again, doing a binomial with a trinomial. So for this one, first, outside, inside, last doesn't necessarily work because now we have a middle, but the concept is the same. We're just going to start by multiplying the first term to everything. Notice that that's what we did here. We did the first term to the first term of the first expression to the first term of the second expression, and then first term to the second. And in this case, because it's a trinomial, we would extend it to the third. So we're just doing extra multiplying. So here, let's start with what we have. We're going to do x times x squared, which is going to give me x to the third. Next, we're going to do x to the negative 3x, which is going to give me negative 3x squared. And then also we're going to extend it. We're going to do finally x to the last term, which is 2, so 2 times x, which is 2x. So that's taking care of multiplying the first term to everything. And it seems silly, but actually drawing these arrows kind of helps you hold yourself accountable to make sure you're multiplying all the terms. Especially when we get into longer polynomials like this, it becomes easier to lose track of what you're multiplying. So if you draw the arrows, it does actually help you make sure you put the terms down. So now we're moving on to the negative 4. I'm going to do negative 4 times x squared, which is going to give me negative 4x squared. Do negative 4 times negative 3x, which is going to give me positive 12x. I'm running out of colors really quickly. What have we not used up? Well, we'll use pink. Sorry, plus 12x. Should probably draw the arrow, right? Negative 4 to the negative 3x, especially since I just told you should do that. And should probably write the right number. Instead of 2, it's a 12. And then negative 4 times 2, which is negative 8. Okay, so again, combining like terms, what's annoying about the FOIL method is it does not put in order. So remember, the box method was really cool because it put everything in order for us. FOIL method does not do that. So unless you decide to FOIL differently. So here we have x cubed, which is by itself. But my x squareds are separated. I have negative 3x squared and minus 4x squared. So I'm going to write those together. Negative 3x squared minus 4x squared. I like to get them together so then I can combine like terms. I then have the 2x and the 12x. So we have to write that plus 2x plus 12x. And then my only constant is 8. Negative 8, actually. And so now I'm in a position where I can finally combine those like terms. We'll actually write it in the same color so there's no confusion. So now combining like terms, 3x squared, negative 3x squared, sorry, minus 4x squared is going to be negative 7x squared. 2x plus 12x is 14x. And then finally that minus 8. So your answer is going to be x cubed minus 7x squared plus 14x minus 8. All right, so this is, again, 2 different methods for doing the same thing. Choose your poison, and we'll discuss as a class which one we want to kind of model going forward.